I want to look at one more example using this limit definition of the derivative, and here we're going to look at a rational function, which is not one that we've looked at so far, so that's why I want to talk about it. Here we have g of x equals x divided by x plus 2. I want to find the derivative g prime of x, and then find the equation of the tangent line at a equals -1, or at x equals -1. Sometimes we'll use x equals -1 instead. So again, I'm falling back on that limit definition of the derivative. Right now, that's all we have to work with. Limit as h approaches 0, in this case, g of x plus h minus g of x divided by h. So let's see if we can evaluate this. Let's see if we can find our derivative. So step 1, again, I'm going to break this down. I'm just going to look at g of x plus h. I'm just going to look at that part here. So g of x plus h is x plus h divided by x plus h plus 2 here. Well, there's nothing I can really do. I can't cancel these because of this plus 2 in the denominator, so let's move on to the next step then. Step 2, g of x plus h, I'm going to take what I found in the last part, which is this piece right here, and then I'm going to subtract my original function, g of x. So I'm going to take x plus h over x plus h plus 2 minus my original function, which is g of x, that's up here, x over x plus 2. Well, shoot. Look at this. I got x plus h plus 2 in the denominator on the left-hand term and x plus 2 on the right-hand term. Can't subtract these two because I don't have a common denominator, and I can't unfortunately just add in a plus h on this right-hand denominator. So I am going to have to get a common denominator. Whoops. I am going to have to get a common denominator. The way I'll do that, I'll multiply this right-hand term by x plus h plus 2 over x plus h plus 2. The left-hand term I'm going to multiply by x plus 2 over x plus 2 to get a common denominator. So let's see. Right here, I am going to want to FOIL those out. So let me do that. X times x, I've got x squared. X times 2, I've got plus 2x plus xh plus 2h, looks like. All over my denominator. Again, this is one of those circumstances I'm going to tell you, just leave it. Don't worry about it. I'm going to leave this as x plus h plus 2 times x plus 2. Minus over here, I can just take this x and distribute that. That's pretty nice. X times x, I've got x squared. Again, this this one, this minus sign here, I want to be really, oops. It's a minus sign right here. I want to be really careful of. You can, if you want to, just change this to a plus negative right from the beginning, and I think that'll actually solve a lot of your problems. But let's suppose that we didn't. Well, if x squared plus xh plus 2x all over, again, denominator, I'm going to say keep exactly the same. I'm going to leave that as x plus, here, let's even just write them in the same order. X plus h plus 2 times x plus 2. If I didn't distribute that minus sign right here in this step, I am going to have to do it right here. And remember, I want to subtract all of these terms in my numerator right here. So I'm really subtracting x squared, I'm subtracting xh, and I'm subtracting 2x. I think the easiest way to do it is just to change it to a plus sign and change all the signs on the numerator. So let's see, x squared plus negative x squared, look at that, those two cancel. Xh plus negative xh, those two cancel. 2x plus negative 2x, those two cancel as well. So the only thing I'm left with then is 2h divided by x plus h plus 2 times x plus 2. Oof. So there's a lot happening here, but I will say at this point, for this problem, the hardest part's already done. So okay, we have the numerator. What do we need to do next? Well, we need to take that, we need to divide it by h. So let's divide this by h. In step 3, I'll have g of x plus h minus g of x, what I just found last time, divided by h. So I'm going to take 2h divided by x plus h plus 2 times x plus 2. Take this whole thing and divide it by h. So it looks a little bit messy because I have fractions inside of fractions. But remember that I can think about that h in the denominator, I can think about that as h over 1. And then rather than divide by h, we say, well, what if instead I multiply by the reciprocal? In my denominator, those two h's will cancel, and in my numerator, look at this as well, those two also cancel, which is exactly what I wanted. Last step then, I have pretty much everything. I've got all of this. The only thing that's missing now is the limit. So let's take that limit. Step 4, limit as h approaches 0. I have 2 over x plus h plus 2 times x plus 2. And again, if you've been simplifying along the way, we should be able to just take 0, plug that in for h. So 2 over x plus 0 plus 2 times x plus 2. This is 2 over x plus 2 times x plus 2. You could leave your answer like that if you wanted, I don't mind. Or you could say this is 2 over x plus 2 quantity squared, or you could go and FOIL that out. However you want to write it, it's up to you. But this is my derivative, g prime of x. So here is g prime of x. So that's the first part of my problem. It said go find the derivative. So we found the derivative. It looks like I'm going to run out of room, so I'm going to have to go back up to the top here. So let me just write down my derivative before I forget it. So we said g prime of 2 is g prime of x, excuse me, g prime of x is equal to 2 over x plus 2 quantity squared. Let me just double check that. Yes, 2 over x plus 2 quantity squared. And I want to know now, so here's the first part of my answer. I want to know, okay, using this, I want to find the equation of the tangent line at x equals -1. So that's the second part of my problem. So let's make some room here. Writing the equation of the tangent line, hopefully that's starting to feel really familiar, and hopefully we kind of can predict what this is going to look like here. If I want to write the equation of the tangent line, I need a point, so I need an x value and a y value. I have an x value, that's -1. The y value I don't have, and I need a slope. I don't have that either. So let's start with the y value. I think that's a little bit easier to find. If I want to find the y value, right, this is my y value, I'm going to look to my original function. The original function is what tells you the y value. So g of -1, I'm going to plug my x value of -1 in to find our y value. -1 over -1 plus 2. You have -1 divided by +1, which gives me a y value also of -1. So that's my y value. I still need to find the slope, though. I still need to find the slope of the tangent line. Well, how do I do that? Remember, the slope of the tangent line, this is really equal to the derivative at -1, g prime of -1. So I'm just going to take -1, plug that into my derivative, and then that will tell me the slope of the tangent line. So g prime of -1 is 2 over -1 plus 2 quantity squared. Again, I'm looking at this guy right here, this derivative that I just found. I'm now using it to tell me the slope of the tangent line. This is 2 over, let's see, +1 squared, 2 over 1. This is 1, oh, excuse me, this is 2, which is my slope. That's m. So m equals 2. That's my slope of the tangent line. At this point, I have everything I need to write the equation of the line. So we would say y minus my y value is -1 equals m, which is 2 times x minus my x coordinate is also -1. So this is really y plus 1 and x plus 1. Y plus 1 equals 2x plus 2. Y equals 2x plus 1. There's the equation of my tangent line. This is a really nice example because this is, I think, the first time that we're going to have to really reconcile the difference between these two quantities, g of -1 and g prime of -1. Because they look so similar. The only difference is that apostrophe, that prime. They tell us two very different things. G of -1, that's what tells us our y value. G prime of -1, that's what tells us the slope of the tangent line. In many of these problems, we're going to be working with both of these two, so it's really important that we understand the difference. We understand that the original function, g of x, right? The original function g of x, this gives you the y value. The derivative, this tells you slope of the tangent line. So that is going to be a challenge going forward, but it's going to be a really important idea that these two values tell us two very different things. They're both very helpful, but they tell us two different things, and we have to keep those two things straight going forward.